Today we're going to learn to draw free body diagrams, or sometimes called force diagrams. A free body diagram is a special kind of drawing that shows all the forces acting on an object. And this includes field forces like gravity, it includes contact forces, pushes and pulls, and you may want to take just a moment to review what our field forces and our contact forces are, so that you have a good idea coming into this, the kind of forces that you may be adding on to your free body diagram. Now, the free body diagram shows all the forces acting on an object. So it's what's happening to the object that you're drawing the free body diagram for. And the diagram itself is going to show the relative magnitude of the forces, and it's going to show the direction of the forces. And we're going to use vector arrows to represent those things. These are vector diagrams, so the direction in which you draw the arrow matters, and the length, the relative length of the arrow matters. And then we make sure that our free body diagram is carefully labeled, and we're going to use a special kind of force label. And we're also going to use any numbers that we actually know, any magnitude or strength of the force. We're going to put that right onto the diagram. This means that diagrams can be qualitative or they can be quantitative. A free body diagram with no numbers, with just the relative lengths of the arrows, some arrows shorter, some arrows longer, that's going to be a qualitative free body diagram. It's just showing qualities, it's not showing actual quantities. A quantitative free body diagram shows the exact magnitude, the exact strength of each force. So you're going to have a number. You're going to actually have every single arrow on the free body diagram calculated out so that you know exactly how strong every single force is acting in every exact direction that your arrow is drawn in. We're also going to be able sometimes to have semi-quantitative free body diagrams somewhere in the middle. Maybe not every force is going to have a number attached to it, a strength, but some of them will. Now, here are your basic instructions for drawing a free body diagram. And you will notice that we have a system, we have a way to go through this that gives us the best chance to draw the most accurate free body diagram. There is a copy of this slide in the reading guide for how to draw a free body diagram in your OneNote. And what you're going to start out doing is, number one, you're going to identify the object that you're drawing the free body diagram for. It's important because an early mistake that some people make is they put forces that are acting on different objects onto the free body diagram. You have to know the exact object that you're considering. And then you're going to draw a dot or a small box to represent the object. I always draw a dot, but you may see some in other places online that have a box drawn. Totally fine. This dot or box represents the center of mass of the object. Then you're going to start to identify forces that are acting on the object. This is not what the object itself is doing to anything else. It's what's being done to it, which is an important distinction. First, identify any field forces. Now remember, we only have 3 field forces. We have gravity, we have the electric field, and we have a magnetic field. We are not going to be dealing with the electric and magnetic field from here on out, so we just have to make sure, is gravity acting on this object? If so, you're going to draw an arrow in the direction that gravity is pulling the object. Once you've identified and drawn on any of the field forces, then you're going to identify any contact forces. If you have a picture given to you of the scenario or you've drawn one, I think it's a good idea to just draw a circle around the object and anything touching that object may be exerting a contact force. If it's not touching it, it can't exert a contact force. And so for everything that's touching your object, you identify, is there a contact force here? If so, in what direction is it pushing or pulling? You draw your arrow on there, you label it, and if you know the magnitude or can calculate the magnitude, you do that. You're going to do that for every single contact force, every place that you have something touching the object as you go around your circle that you've drawn. And finally, you're just going to check the lengths of your vectors. If you know magnitudes or a relative strength of the forces, you want to make sure that those are accurate. If you have something, a 10 Newton force, and then you have a 30 Newton force, that 30 Newton force's arrow should be about 3 times longer than your 10 Newton force. There are free body diagrams made on graph paper where they measure everything out to scale completely. We're not going to be that detailed, but I am checking to make sure that you have a sense for the relative strengths of the forces involved. Okay, let's try an example of a free body diagram. Now, consider a skydiver falling from a plane. This is something called free fall. What forces are acting upon her? Okay, so first thing I'm going to do, I'm going to draw a little sketch. Here's the ground with the little trees. And I'm going to draw a person in free fall. That's really good, huh? And whoosh, whoosh, whoosh. She's kind of falling through the air. And that's my picture. Okay. So let's just follow the directions. Number 1, identify the object that I need to draw the free body diagram for. It is for the skydiver. And so I'm going to put a circle around her. That's going to help me a little bit later identify my contact forces. It's always a good idea to do that. Number 2, draw a dot or a small box to represent the object. All right, I'm going to draw my dot right there like that. Number 3, identify any field force acting on the object. Okay, now the only field force that I have to ask myself about is gravity. Is gravity affecting her? Well, sure, yes, absolutely. If so, what direction is gravity pulling or pushing her in? And in this case, gravity is pulling her toward the earth, toward the center of the earth, which would be straight down. So I draw an arrow straight down. I'm going to label that force of gravity on the skydiver by the earth. So I remember we have that special notation we use, that feeler-dealer notation. We label what the force is, write it out. Then who feels the force? Well, the skydiver. The force is on the skydiver. And what or who deals the force? In this case, that's the earth. Okay, so we're done with field forces. Now we go to number 4, identify any contact force. Okay, so here's where I look in my red circle. What is touching this skydiver? Well, there's nothing touching her except for air. And then I have to ask myself, does the air exert a force on her? And if we're considering air resistance and friction, which I'm going to say today we are, then I have to consider that force of air resistance. And in the case of friction, and air resistance or drag is just friction with the air, friction always acts in the opposite direction of motion. So if she's falling, moving down, then friction, air resistance or drag is going to act up. Now, I'm going to draw an arrow then up. And I'm going to say this is the force of either air resistance or drag on the skydiver by the air. Okay, are there any other contact forces? As I look around her body, nothing else is touching her. So no, I'm done. Those are the two forces acting on my person. Now, I'm going to check the lengths of my vectors next. I don't have any numbers, okay? I don't have any way to calculate how strong the force of gravity or how strong the force of drag is. All I do know is that she is falling down, which means that right now, for our purposes, the force in that downward direction is going to be larger than the drag force. As she falls, she's still kind of speeding up. And so you can just kind of leave the arrows different sizes, but another helpful way to mark the relative magnitude is to put hash marks on the arrows. So I might put 1 mark here and 2 marks here, and that would tell me that my gravitational force is much longer or greater than my drag force. And that's all there is to it. You've gone through 1 through 5. If you follow that process every time, your chances of coming out of it with a really good, correct, accurate free body diagram, your chances are good. Follow the process. Don't get lost and look at it and think you have to just know what to do. This process tells you how to go through it step by step. Okay, now it's your turn. I'd like you to create a free body diagram for each of the following 4 situations. For each scenario, I'd like you to draw a picture, an actual little sketch of the situation, then circle the object like I circled my skydiver in red, then follow the 5 steps to create a free body diagram for that situation. Make sure you label your free body diagram with that feeler dealer notation. You may want to have that commonly encountered forces page open in your OneNote to help you kind of think about what forces may be involved. Your reading guide on Intro to Force may also help you. And we will be going over these together in class in just a bit. So go for it. If you get stuck, just follow the process, do what you can, move on to the next problem. Good luck.